Welcome back to Pure Science Education. In this video, we'll be looking at how we name things when they react with metals. So as you can see, if I was to react the acid with a metal, I get metal plus acid. That gives me a salt, depending on which acid and metal I use, and hydrogen gas. So if I was to look at this particular example, because I have used hydrochloric acid, make a chloride salt. Here I use sulfuric acid and make a sulfate salt. But what is important to know is the metal has to be above hydrogen in the reactivity series. Let's have a look at some other naming. So how do we name salts? The first part in naming salt is based on the type of metal, and second depends on what acid you are using. So if I use a hydrochloric acid, I made a chloride salt, a sulfuric acid, a sulfate salt, and you will notice that I put in the spellings that have been changed for sulfate, and finally nitrate will give you nitrate salt. So the way you can recognize if you're trying to work out in the exam if they have given you the acid what salt is forming, or if you've been given the salt, you can go back and try to work out what acid you had used in this equation. So if I was to do an example, I've got sodium chloride, then what acid do you think I have used? And the answer is I would have done sodium plus hydrochloric acid, which would have given me sodium chloride and hydrogen. So like I said, it really depends on the type of acid what salt you form. Let's look at carbonate. So if I was to look at carbonate, the formula of carbonate is CO3 2 minus charge overall. So a carbonate breaks down to give you carbon dioxide and the salt and water. So again, when you're looking at the reactions and you're not quite sure, it's quite important to look at byproducts. So one of the ways to remember this for an exam is if you have a carbonate on the left hand side, you will always make a carbon dioxide on the right hand side. Let's go through the example. I have got lead carbonate with nitric acid. Now, if you look at the previous slide, it will make a lead nitrate because I start with the nitric acid. Now, if you look at the carbonate part, it'll give you the carbon dioxide and water. Another example is sodium carbonate, this time with sulfuric acid. So again, the sodium and sulfuric acid will make a sulfate salt, and the remaining structure will give you water and carbon dioxide. Now, there is always a confusion in an exam between base and alkaline, and students quite often don't understand. So base is something that neutralizes an acid. So if you look at the pH scale, acid is between 1 and 6. And if you look at an alkaline, then that is between 8 to 14. So what is the difference between an alkaline and a base? So a base is something that dissolves in the water, and then when it dissolves in the water, it's called an alkaline solution. Base are often metal oxide or hydroxides. So if you was look at oxide, then you're reacting the metal with oxygen, and if it's a hydroxide, then hydroxide are OH minus. So if I was to do an example, so I've got magnesium plus oxygen, that gives me magnesium oxide, and to balance it, I've got to put 2 and 2 there. So that's one of the reactions, and for hydroxide you will have OH minus in your metal. So If I had an acid that reacts with a base or an alkaline, then an acid plus base gives you salt plus water. Again, you need to look at the name of the salt. So because I've used sulfuric acid, I make a sulfate salt. Here I use hydrochloric acid, I make a chloride salt. And finally, if it's to summarize those reactions, acid plus metal gives you salt plus hydrogen. Depending on the type of acid, you will name your salt. Acid plus carbonate gives you acid, plus carbonate gives you salt, water, and carbon dioxide. And finally, acid plus base gives you salt plus water. I hope you found this video useful. Thank you for listening.